Hey, Math 250B students. Hello. You haven't seen me since Wednesday. I thought you probably missed me by now. And I know people have been working on the homework assignment, and there's, I think, a couple of examples I could show you here that I didn't get a chance to do during class that would help you really understand the different things that can happen in doing the Gaussian elimination method to solve a system of equations. So I'm just going to make this really quick. I don't want to take too much of your time, but I just want to show you three quick examples of solving a linear system. So the first one is x plus y equals 1 and x plus 2y equals 1. That's just the equations of two lines. And we could actually draw those lines if we wanted to visualize what's happening. So x plus y equals 1 would be a line something like that, right? It goes through 1, 0, and it goes through 0, 1. And on the other hand, the line x plus 2y equals 1 goes through 0 and 1/2, and also through 1, 0, and so it's the line that looks like that. Okay, so actually we can already tell that this linear system has just one solution, which is the point 1, 0. But I thought it might be helpful for us to see how that comes about from the Gaussian elimination perspective. So if we write down the augmented matrix that goes with this system, it's going to look something like that. So 1, 1 augmented with 1, and 1, 2 augmented with 1. If I perform the ERO that adds the negative of the first row to the second row, what will happen is the first row stays the same, but we take the negative of the first row and add it to the second row. We're going to get that 0 right there, which is what we want, and then we're going to get a 1 and then a 0. So my pivots actually are already determined. I just drew them right here. And this is a system that has no free variables because every variable is pivoted, right? So both x and y are pivoted variables here. The second equation here on the bottom line really says that 0 times x plus 1 times y adds up to 0. So y is equal to 0, and then if I take that and plug it into the equation that corresponds to the first line, which was x plus y equals 1, we find out that x has to equal 1, and this is exactly the solution, 1, 0, that the picture showed us. Okay? So this is the situation when we get exactly one solution. There's a pivot in every column, okay? To the left of that bar anyway, there's a pivot in every column. Okay, no free variables. Okay? Let's take a look at the second equation. The second system, I should say. Notice it's two copies of the same equation. So in this case, we actually only have one line, and any point that is on that line is going to satisfy, obviously, both equations because they're the same. If I write it down in terms of a matrix, I'm going to have first equation, 1, 1 augmented with 1, and the second equation is 1, 1 augmented with 1. And if I just take the negative of the first equation and add it to the second equation, you can see that we will end up getting a row of zeros on the bottom there. Okay? So this time I only have one pivot in my row echelon form, which means I do have a free variable. The free variable being the one that corresponds to the second column, which is y. Remember that we label these columns. So y is free, so I'll just call it t. And then x can be solved for from either equation up there, and it's just going to be 1 minus t. So my solution set this time would be the set of 1 minus t, comma, t, such that t is an element of the real numbers. An infinite number of solutions indexed by this parameter t. This is really a parametric description in the Math 250A sense. It's a parametric description of the line x plus y equals 1. That's what we've ended up with here. Okay? So this is the set notation that I showed you in the example in class on Wednesday where we had infinitely many solutions as well. On this example, we only have the one unknown, which is the one free variable, which is the y variable. Okay? Finally, here's one more example. X plus y equals 1 and x plus y equals 2. So if you think about that, we still have the same line, x plus y equals 1, and the line x plus y equals 2 is parallel to it. And you can see right away that these lines never cross. that should mean that there are no solutions here. Okay, let's see if our Gaussian elimination method confirms that for us. If we write down the augmented matrix again, it's going to look something like this: 1, 1, 1, and 1, 1, 2. And if I once again multiply the first row by -1 and add it to the second row, I'm going to get the first row staying the same. The second row is going to become 0, 0, and 1. This time, I get a pivot in the far right column. That is a problem, because if you think about what this bottom equation or this bottom row means, it's telling us that 0 times x plus 0 times y equals 1. In other words, 0 is equal to 1. Now, of course, we know that that's not possible, so this is an inconsistent system, as we could imagine from the equations. And the real tip-off that it's going to be inconsistent is the fact that we get this pivot in the far right column. Okay, guys? So there's 3 scenarios that can happen. You can either get no solutions, which happens exactly when we have a pivot in the last column, or you can get infinitely many solutions, which is this middle scenario where I have an unpivoted column and I don't have any pivots in the right-hand column, the far right column, but there is an unpivoted column, at least one unpivoted column. Okay, so there's going to be free variables leading to infinitely many solutions. And finally, the case we looked at first, where there is no pivot in the far right column, but every column to the left of that augmentation bar is pivoted. So there's no free variables. We get exactly one solution. Punchline is, every linear system has either one solution, infinitely many solutions, or 0 solutions. I hope that's a little bit helpful in terms of the insight. I didn't do a lot of EROs here with these examples, but I just wanted to show you sort of what can happen as a result of the Gaussian elimination process. So, hope it makes sense. If you have any questions about it, of course you should feel free to stop by and ask me anytime. All right, thanks for watching.